Hello everyone, this is topic number 23, Lagrange's method of undetermined multipliers. Okay, so already we have learned how to find the maximum and minimum of functions of two variables. Here also we are going to discuss the same. We are going to find the extreme values subject to a constraint. Okay, so here they will be specifying the condition. So based on that we are going to solve it, right? So Lagrange's multiplier method, let f of x comma y comma z is equal to 0 be the function whose extreme value should be found subject to the constraint phi of x comma y comma z equal to 0. They will be specifying the condition also. So while solving these type of problems, we need to construct a new function capital F with the combination of these two. That is f of x comma y comma z plus lambda times phi of x comma y comma z. This lambda is nothing but the Lagrange's multiplier. And solving these equations for extreme values, that we are going to find what is the differentiation of f with respect to x, f with respect to y, f with respect to z, and f with respect to lambda. That is nothing but the constraint equated to 0. Okay, so we are going to solve these equations for getting the extreme values. The values of x, y, z, whatever we are going to obtain, we call it as a stationary value of f of x comma y comma z. Right. So now let us see a problem here. See this. Here we are going to find the dimension of the box that requires the least material for construction of the box, being opened at the top and having a volume 32 centimeter. So the condition is that volume is given, volume is equal to 32 centimeter, and also we have another information that the top of the box is being open. Okay, so it means that whenever if you imagine a box, you consider a cube, if it is open at the top, totally how many surfaces will be there? It will have only 5 surfaces. Instead of 6, it will have only 5 surfaces. Okay, so let us see this with the help of a diagram in 3 dimension. So this is x axis, y axis and z axis. Let us draw a cube like this. So here you have a cube, which is nothing but a box. Okay, so in the top let it be open. So in the top it is open, right? So totally how many surfaces will be there? Only 5 surfaces will be there. So what is the surface area? Let us first define. Let x, y and z be the length, breadth and height of the box. Okay, we are going to consider x as the length of the box, y as the breadth of the box and z as the height of the box. Okay, so what will be the surface area now? Since it is open at the top, surface area will be equivalent to surface area of the box will be equivalent to C. So xy plane, only one xy plane is there. In the top is also it is a xy plane, but it is open. Okay, only one xy plane will be there. And when you come to zy plane, both the surfaces, that is both the planes will be there. That is 2 times of zy will be there. And similarly xz also it will be 2 times. Okay, only one surface is open. So we are considering only one xy plane. Okay, and given the condition that volume is equal to 32. So this is nothing but volume of a cube is nothing but x, y, z. So x, y, z is equal to 32. So this is nothing but phi of x comma y comma z is nothing but x, y, z minus 32. Now let us consider the function, construct the function capital F, which is equal to small f plus lambda times phi. Small f is nothing but the surface area, that is nothing but xy plus 2yz plus 2zx plus lambda times of a phi function, that is xyz minus 32. So let us mark this as equation number 1. So we are going to differentiate this with respect to x, y and z, then with respect to lambda. So let me rewrite this function again. F is nothing but xy plus 2 times yz plus 2 times zx plus lambda times xyz minus 32. So let us differentiate this with respect to x first. What is dou f by dou x? When you differentiate the first term, you have x into y. So y will be treated as a constant, it will remain. What will happen to the second term? It will become 0. And in the third term, z and 2 will be a constant. So 2z will remain. And the remaining is lambda times of, you are differentiating with respect to x. So yz will remain as a constant. Okay. So it is y plus 2z plus lambda times yz minus 32. Let us mark this as equation number 2. Then now we are going to differentiate dou f by dou y, that is you are going to differentiate f with respect to y. So what will happen, it will give you x plus 2z then plus lambda times, here you are going to differentiate with respect to y, so remaining will be xz minus the constant term will become 0. Once again here also the constant term will become 0, so this is 0 here. So here also it is 0, here also it is 0, okay. So this is equivalent to x plus 2z plus xz into lambda, okay. Let us mark this as equation number 3. Now let us find dou f by dou z. So when I differentiate this with respect to z, this will give you 0 plus 2y plus 2x plus lambda times, when you differentiate this x, y, z, it will give you xy minus 0. So this is 2 times of y plus x plus xy into lambda. Let us call this as equation number 4. Similarly, what is dou f by dou z? Dou f by dou z will be lambda, okay, dou f by dou lambda. So this is, so dou f by dou lambda will be equivalent to xyz minus 32. So this is equation number 5. Okay. Now let us equate everything to 0. That is dou f by dou x equated to 0, dou f by dou y equal to 0, then dou f by dou z equal to 0, then dou f by dou lambda equal to 0. So when dou f by dou x equal to 0, you will get y plus 2z plus lambda times yz equal to 0. So this is lambda yz is equal to minus of y plus 2z, or we can write lambda equal to minus of y plus 2z divided by yz. Now similarly, dou f by dou y equal to 0, that is nothing but equation number 3. So equation number 3 gives x plus 2z plus xz into lambda equal to 0. Therefore, the value of lambda is nothing but minus of x plus 2z by xz. Similar way, from the equation number 4 we get 2 times of y plus x, 2 times of y plus x plus xy lambda equal to 0. From here you can get the value of lambda as minus 2 times of y plus x divided by xy, okay. And from the equation number 5 we get xyz is equal to xyz minus 32 equal to 0, that is nothing but xyz is equal to 32. So we can observe that all these things are nothing but lambda. That means that lambda is equal to, so from the first equation it is minus y plus 2z divided by yz, which is equivalent to minus of x plus 2z divided by xz, which is equivalent to minus 2 times of y plus x divided by xy. So now let us equate these two as one ratio and another combination as these two. So what will happen, this is minus of y plus 2z by yz is equal to minus of x plus 2z by xz. So what will happen, z will get cancelled, negative also will get cancelled, and the remaining will be x times of y plus 2z, which is equivalent to y times of x plus 2z. When you multiply, this will give you xy plus 2xz. This is nothing but yx plus 2zy. Okay. So yx, x and xy will get cancelled, and the remaining will be 2xz is equal to 2zy, and 2z will get cancelled, and you will get the answer as x is equal to y. So we have got a relation between these two. Similarly, let us compare these two combinations. It is minus of x plus 2z divided by xz. This is equivalent to minus 2 times of y plus xy. So here x will get cancelled, same way negative sign also will go, and when you cross multiply, this will give you y times of x plus 2z is equal to 2z times of y plus x. When you multiply this, you will get yx plus 2yz is equal to 2yz plus 2xz. Okay, 2yz and 2yz will get cancelled and the remaining will be yx is equal to 2xz and you are going to get it as y is equal to 2z. So, we can easily observe that we have got a relation between all these three, that is x is equal to y is equal to 2z. Okay. So, based on this we are going to find the value of these things. And what about the another 50 equation? Substituting all these values in the 50 equation, you will get, I will do it in this place. We are going to substitute in the equation number 5, that is x, y, z is equal to 32. When you substitute, what will you get? X is equivalent to y. So, it is x into, let us write this as x by 2. Z is nothing but x by 2. So, this is equivalent to 32. So, this is nothing but x cube is equal to 32 times 2 will give you 64. This is nothing but 4 cube. So, we have got the value of x is equal to 4. Since x and y are equal, is this nothing but x is equal to 4 and y is equal to 4 and z is nothing but x by 2. Okay, from these two combinations we can get z is equal to x by 2. So, that is nothing but 4 by 2. Therefore, the values of x, y, z are nothing but 4, 4, 2. Okay. Therefore, the dimension of the box, is 4, 4, 2. Okay.